So for our first question here, we have an aircraft that is flying west for 350 kilometers. All right, so due west, and then it's going to go northwest, so we'll draw low. Okay, so due west, 350 kilometers. Okay, then it turns and travels 240 kilometers at 35 degrees north of west. All right, so my reference is still west. Going to go 35 degrees north of that. Okay, so we're going to have 240 kilometers there. This angle's 35 degrees, x, y. And then our overall displacement is that kind of crooked line that's supposed to be straight. Here's y, here's x. That's going to be my overall displacement. Now, the question doesn't want displacement, it wants velocity. But I have to get displacement first. Okay, because velocity is total displacement over total time. All right, my next step then, find all the x's and all the y's. So first, give them a mark for picture. All right, black x is 350 kilometers west. Black y is 0 kilometers north. I'm gonna have one mark for that. Okay, then we got to find the red x and y. So red x is the adjacent side, so that's going to be the coast of 35 times 240 kilometers. Whoops. All right, it's 196.596 kilometers, and that is also west. All right, for y, sine of 35 times 240. Gives us 137.658 kilometers, and that's going to be north. Okay, one mark each for those. So we're up to 4 here. All right, I need to calculate my total x and total y here, so green x and green y. All right, not going to get a mark for those this time just because it's, I mean, there's not much to do there. For green x, I'm just adding 350 and 196. Whoops, 196 point. Okay, so 546.596. Kilometers, and that's west. And for the y component, there's only one y, so it's just going to be our 137.658 kilometers north. All right, my next step is I got to calculate my overall displacement. So my overall displacement is a Pythagorean theorem calculation. My 146 squared plus my 137 squared. Okay. Wait a minute here. That's 546, isn't it? Sorry, I don't know why I wrote 146 there. Something just looked really wrong. Nobody said anything. Just let me write stuff down that's wrong. Okay, so now we've got those two things, so there should be 546. Okay. 500 and, no, actually we can just use the answer there, answer squared, okay, plus 137.6583447 squared. All right, so my total displacement here, the total displacement of the plane is 563.66 kilometers. $63, not 43, 63.66 kilometers. All right, one mark if they did that. Okay, so we're up to 5. Then we got to find the angle. Theta is going to be tan to the -1 of the opposite side, which the way I drew the triangle is x. So that is our 546, okay, divided by 137, obviously with all the decimals in place. All right, so I'm getting an angle here of 75.86 degrees. And that is going to be west of north. All right, 1 mark for that step. So now we're up to 6 marks. In order to get the average velocity is total displacement over total time. So I'm going to use my 563 with all the decimals divided by the time. And they told us that this takes 2.5 hours. All right, so this plane is traveling at 225.47 kilometers per hour. All right, now that's another mark. That's 7. Final answer. Okay, final answer can only have 2 significant figures because the 2.5 only has 2 significant figures. So my final answer is going to be 2.3. My velocity will equal 2.3 times 10 to the 2 kilometers per hour at 76 degrees west of north, or at 14 degrees north of west. 8th and final mark. Okay, questions on that one? Okay, that was once on a unit exam. All right, question number 2. We have a helicopter flying around looking for survivors of a shipwreck. Okay, the first vector is 86 kilometers at 30 degrees south of east, and then 95 kilometers at 15 degrees west of north. So the first thing I'm going to draw is the south of east vector. So here's east, okay, and I'm going to go 30 degrees south of that, like so, 86 kilometers. So there's y and there's x. All right, my second vector is west of north, 15 degrees, and it's 95 kilometers. So it's actually longer than this vector that I just drew. All right, so I'm going to use blue for that one and give myself a reference line that's north, and it's only 15 degrees, so it's a narrower triangle. So here's x, here's y, there's my 15 degrees. This is 95 kilometers. Which means my overall displacement give them a mark for that drawing. Okay, 1 mark for the diagram. Again, was scale kind of important here? Since it backtracks on itself, scale's kind of important. And the thing that people mess up is not the length, it's the angles. Right? And I tried to pick 2 angles that would be easy to make scale out of. One's twice as big as the other. Okay? Sometimes I'm like that. Sometimes I'm nice. Not always. Okay? Today. So here's what we have to do next. We've got to find all the x's and all the y's. So for black x, okay, that's the adjacent side. So it's going to be the cos of 30 degrees times 86 kilometers. $30 is better than 3. All right, so 74.478 kilometers. Okay, and that is going to be east. Okay, and then y is going to be the sine of 30 degrees times 86. So that'll be 43.0 kilometers south. Okay, 1 mark each for those. Everybody with me on that? Okay, then we got to do the blue triangle. All right, blue x is the opposite side this time, so sine of 15 times 95 kilometers. Right, gives us 24.588 kilometers, and that is going to be west. Okay, and then for y is the adjacent side, so cos of 15 times 95 gives us 91.763. Okay, so that'll be cos of 15 times 95. Okay, and that is kilometers, and that is north. Okay. All right, 1 mark for each of those. So we're up to 5 marks here. Now that I have those, I've got to calculate my overall x and overall y. Everything backtracks in this question. So I need to do some subtracting, make one direction positive and the other negative. All right, so in the first one here, okay, I'm going east quite a ways, and I'm going to make east positive. So that's going to be 74.478 minus the x component from the other one, which was 24.588. All right, so we got 49.0890 kilometers, and that ends up being east. 1 mark for that. Okay, for y, I'm going to make north positive. Okay, the bigger number north is 91.763 minus 43. Okay, it's 48.763. Kilometers north. All right, just looking at these two numbers here, 49 and 48, are they pretty close? So what should my angle come out to be close to? Around 45, okay? It should be around 45 because the two sides that aren't the hypotenuse are almost exactly the same length, all right? Which means that I'm going up and over almost the same amount. All right, that's just something we kind of want to think about in our head so we can check our answer after we've got it. Now that I've got those numbers, all right, that's a mark there. Okay, then I've got to do a Pythagorean theorem calculation to get the overall displacement. So that'll be 49 squared plus 48 squared. Okay, obviously with all the decimals in there. All right, so we got 69.763. Kilometers. All right, 1 mark for that step. Then I've got to find theta. So tan to the minus 1, go back to my drawing. The way I drew this, x is opposite and y is adjacent. Okay, so I'm going to have the 49 over the 48. All right, so I'm getting 45.65 degrees. And the way I drew my triangle, that angle is east of north. Okay, so now I've got all my stuff figured out. So that's a mark. Sorry, in the Pythagorean theorem we already said was a mark. Okay, now I need to find the overall displacement of the helicopter in the right number of significant figures, which according to this question is 2. Okay, so I'm going to have 70 kilometers. So my overall displacement is 70 kilometers at 46 degrees east of north or at 44 degrees, north of east. Okay, that should come out to 10 marks. Okay, give them a mark at a 19. Put it at the top where I can see it and give it back to them. Before you hand it in, double check that your first and last name is on that quiz somewhere.